Hey grade 7, welcome to another exciting edition of Mr. V Teaches Math, and today what we're going to get a chance to do is carry on with our learning in data management. We're going to be using samples to try and make predictions as they apply to larger groups of people. And so we're going to use the sample to make predictions and relate this is like the technical term, to relate the accuracy of a prediction to the sample size and determine whether the sample is biased. Whoa, huge things going on here. All we're trying to do is we're trying to be able to, if we're going to conduct a survey, rather than having to ask everybody, ask a few people and make sure that we can use that result to apply it to the larger group. I hope that's a little bit clear. Now I have a fairly long, lengthy problem here. I don't need you to, I will read it out to you, so I don't need you to strain your eyes on this one, but let's imagine that in London, Ontario, there are about 400,000 people who live there. That's roughly true. There's a little bit more than that. My sister, who lives in London, thinks a new community swimming pool should be built, and she wants to see how many people agree with her. So, instead of asking each of those 400,000 people, she decides that she's going to ask a sample of the people, and she plans to use the responses to predict how many people in London want a new community pool. So my sister first decides how many people she's going to ask. This is what's called a sample size. My sister decides that she's going to ask 400 out of the 400,000 people. When choosing people, my sister has to be sure that her sample will not yield biased results. So for example, you don't want to ask, only women, or only men, or only people between the ages of 12 and 14. You want to make sure that the sample size, that it accurately represents enough people, okay? So, we move on to this. And supposing that her results are not biased, and supposing that she found that 240 people are in favor of a new community pool, how can we use this result to make a prediction? And so what we're going to do is we have this bit of information here that 240 out of 400 are in favor of a pool. So we can write that actually as a fraction, 240 out of 400, and from that number we can actually convert it to a percentage. So we'd have 240 divided by 400 times 100, which actually gives us 60%. So what this means is that 60% of people that she surveyed, of the 400 people, are in favor of a new community pool. Now, assuming for a second that these results are not biased, what we can do with this is we can say, okay, so now what we need to do is find out what 60% of 400,000 is. You use a small sample to try and make predictions of a larger group. So if we're going to apply this percentage in favor from the sample size to the larger number, this is how we have to do it. And the way that we do it is to convert the percent to a decimal. So it's 60, and then the of becomes times. So it's 0.6 times 400,000. And when I do that, I find out that 240,000 people, if my sister's results are not biased, 240 out of the 400,000 people should be in favor of this pool. So that's over half of the population of London would be in support of this community pool. And so when you work on these problems, you are finding, percentages of the small sample size and applying that percentage to the larger number like we did here. And so that's a lot of what the problems that you'll be working on page 307, that's what you'll be working on. So I only need to give you hopefully the one example today, and then tomorrow during class, if you're still unsure, I can help you out further. But for now, use that one example, and have a great night.